p-values. So I passed out your calculators, guys. We're going to do this using the calculator. We could do it using our T table, right? Our table B. So follow along so that you will know how to do this with your calculator. All right. So let's look at A. We're going to find the p-value for a test of, and it's hard to see. Our null hypothesis is that mu is equal to 10, and our alternative hypothesis is that mu is greater than 10. Our sample size is 75, so we have how many degrees of freedom? 74. So let's go ahead and actually use the table, and then we'll also do it on the calculator. All right, so if we have 74 degrees of freedom, we're going to use 60 degrees of freedom if we're going to use our table. And where is our alpha level? All right, guys. So if you're going to use your table, we need to look at what was our T. So we had a test statistic of so we're going to go to our table, 2.33, and we're going to find our value between 2. So it's somewhere in here, right? If we're going to use our table. So that is between 0.02 and 0.01. So we wind up with a p-value between 0.01, sorry, 0.01, I wrote that wrong, and 0.02. Now that's weird, right? I mean, we would, if we had a p-value like that, we would reject the null hypothesis. I don't like that type of a p-value, and that's why I don't use the table very much. I would prefer to get an exact answer. So if we were to take that to our calculator and use our calculator to do it, we would go ahead and we can do that using our scratch pad. Oops. Now we're going to go menu. Statistics, stat tests, and we're going to do a t-test. We are not going to use data. We're going to use statistics. I forget what our, you know what, it was 10 and greater than. So we got 10. Do we have X bar? They've just given us a T statistic on. Gosh, we haven't got X bar. So we don't have a sample. Weird. We just got this test statistic. Is it even possible? No, it's not possible for us to calculate it. So, I'm off to a great start today. We can't use our calculator to do this because X bar is missing, right? So we need X bar to use the calculator. So I guess we'll only be practicing with the table. We'll go back to the calculator here in a moment. Actually, let's skip it. Don't use the table. That's how you use the table. Don't use the table. Use your calculator. There's almost never going to be I don't think there's ever going to be an opportunity, a moment where you're going to not be able to use your table, or you're not going to be able to use your calculator. You're always going to have your calculator. There's not like on this test. There's not like a calculator and a non-calculator part, right? So it's not necessary for me to show you how to do it without your calculator. It's all a calculator. It's statistics. How could you be expected to do these things without a calculator? Some of these calculations are so massive. So, here we go. Let us go through phantoms for a t-test. Alright, here we go. First thing we're going to need to do is enter this data into our calculator. First of all, let's figure out what the heck we're talking about. Abby and Raquel like to eat sub sandwiches like everybody else in the world. Is there a sub sandwich that you don't like? There are so many variations. There are so many variations that, I mean, maybe you don't like turkey subs, but you love meatballs. You like all of them? What a tuna sub. You alright with the tuna sub? You would go? You would go for it? Okay. Yeah, okay. But then, they think that the subs they're getting are shorter than 6 inches.
Oh, yeah, that's true.
So they ordered a quote-unquote 6-inch sub randomly during different times of the next month. And they found the actual lengths of these sandwiches. Interesting. 4.5 inches? I would feel quite slighted at that point. Gosh, I don't know. I'm not liking that. A 7-inch sub one day. That's a good day. So, you know, whenever I'm doing these things, I like to look at the data. I like to talk about it, put it in the context. Because I think it makes it easier for me to answer the questions. I don't know. All right, let's go ahead and do this. And now, let's go ahead and enter the data. So we're going to do a listen spreadsheet. I'm going to call this sub and hope that that's not a function. I bro, no. Okay. I don't want to. I don't want to. All right. Oh, never let me do that before. Okay. Let's enter the data. What I'm going to do is go ahead and enlarge that for you and freeze it so that you can enter it on your own. And then I'll enter it on my calculator. over here. Data has been entered. Got the legwork done. Now, let's go ahead and do our test and then fill in the blanks based on what we have on our calculator, all right? So we're going to have to hit doc, insert, and we're going to need a calculator. And then we're going to hit menu, statistics, stat test. We're going to use a t-test. We are going to use data. And at this point, we got to figure out what our null hypothesis is. Huh? Yeah. So let's rock a P over here. First of all, our parameter of interest is the mean parameter of interest is the mean length of a sub, I guess, from this restaurant. Let's be specific. That's our... Okay. That'd be hard pencil. Okay. Our hypothesis. So our null hypothesis is that mu is 6, right? Our alternative hypothesis is that, well, let's see, are shorter, right? We want to know if they're shorter, so mu is less than 6. All right. We'll get to A here in a second. But that prompted me to get to H. So 6. The list we're going to use is sub. And our alternative hypothesis is that the parameter is less than the actual mu. How do I do that? Oh my gosh. I put it in wrong. Good grief. Yeah, my alternative hypothesis is wrong. Sorry. I don't know what happened there. We're going to have to go again. Sorry. Statistics, stat test, t-test, data, 6. Yeah, I went backwards in my mind for some reason. We're going to choose sub. We want that we believe that the actual mean is less than our mean from our null hypothesis. Sorry. All right. got our p-value. It's interesting though that if we changed it, we would actually reject the null hypothesis, right? So it was a kind of a cool mistake, because it brought up an interesting thing to look at the data about, and an interesting perspective was, if we hypothesize that they're actually making bigger subs, right? It would be fantastic. But but we don't get a p-value that is low, right? So we would actually find that actually the subs are indeed contingent, right? What? In the problem, it is saying at the alpha level of 0.10. So let's go ahead and check assumptions. We got to look at it. Let's go ahead and complete the problem. And I like to do the text at first because, number one, it gives me a lot of data values. Number two, it makes me think about the problem while I'm writing the problem out. It makes me think, like, I already know the answer, so it's kind of easier to write it out. Okay, so let's check assumptions. The data comes from an SRS for sure, and then it appears that it's probably the case, so we have to check. This condition. So, n is, what was n? 24? That's right. So we're saying that the shop makes more than 240 subs a day, right? So we could say it is reasonable to assume that the shop very specific, right? Still checking. So A is still over here. I'm just wanting to not be crunched over there anymore. Is it normal? Well, unfortunately, n is not greater than or equal to 30, right? In fact, n is equal to 24. So we can't just assume normality based on the sample size. We're going to have to actually look at the data. So let's go ahead and use our handy-dandy calculator to do that. We are going to have to insert a data and statistics page, right? We're going to have to look at a graph. Let's arrange it. I don't see, that looks nice, right? That looks pretty nice. Fairly symmetric. I don't see any outliers. Definitely, well, it's symmetric, there's no skewness. So, let's look at what the box plot looks like. It's the easiest, I find that the box plot is the easiest one to copy down. So that's why I'm going to choose, sorry, I'm needing to hit menu. That's why I choose to put my box plot. Look at that, I mean, that looks nice. And it's going to be pretty easy to draw. I'm going to put 4.4. 7.0. I feel like I want to draw a straighter line than that. I'm just being weird about it. So I know I've got an endpoint here, I've got an endpoint here. Our next value is right around 5.2. 5.6. 5.2. So let's go ahead and make our notches. Start it. Okay. Really? Oh, it's sorry. They're going by trees. I'm just going to go shorthand. I was going to make a really nice looking one, but I'm going to just 5.2, 5.2. All right. All right, so there does not appear to be any obvious skewness or outliers. So what are we going to do? We will proceed with a T. We're going to obtain it. No, we're not going to phantom. We're going to phantom. Let's get our test statistic. T is going to be equal to, and now we need our X bar, which is going to be located over here. .677 and 5.677 minus 6 divided by the standard deviation of our sample, which is 0.657 divided by the square root of 24. Which is going to be approximately 0.657 Negative 2.407. Yay, there's our test statistic. Let's get a p-value. So our p-value that we're going to obtain is going to be the area under the normal curve to the left of the value, negative 2.407, right? Always nice to draw a picture. So we're looking at the probability that z is less than negative 2.407, which is 0.012. Approximately 0.012. Rolling right through this. Huh? Definitely below our alpha level, right? So let's make a decision. I guess we'll put M over here. Because I don't think you need a comma there. And I did start a sentence with because, but oh well. We reject the null hypothesis. At the alpha level, 1, 0. Yay, we made a decision. And last, let's state our answer in context. So there is convincing evidence and I'm just going to check if they're being specific about saying during this month. Because really, we only check for during this month. Huh? Yeah. It's really weird. Straight answer. Okay. Anyhow. So I'm gonna go with it. All right, fantastic. We answered A. Let's answer B.
Yeah, 4 minutes.
That's perfect. B is really quick. It's a very simple question. Don't you love nice long math problems? Not these? They're kind of nice. It's satisfying. Okay, given your conclusion in part A, which kind of mistake, a type 1 or a type 2 error, could you have made? And what would this mistake mean in context? Alright, so we decided to reject the null hypothesis, right? So we could have possibly have made a type 2 error and failed to reject the null hypothesis when indeed we should have. Right? What does that mean? It means that there's a chance that for some reason, maybe it's from the data that we got, maybe we just, by some crazy chance, got data that gave convincing evidence against the null hypothesis, when indeed the null hypothesis is true. Alright? Excellent. One down.